Again, each of the metals you've observed provides evidence there's an order of reactivity. Those three words, order of reactivity, quite important. Okay. Now, if you bring together all of your observations, we can order the metals from least reactive to the most reactive. Okay. Now, the most reactive metals belong to groups 1 and groups 2. And they're the ones that we've seen. So if you have your periodic table in front of you and you put your finger on group 1, so the first column of the periodic table, you'll see metals like lithium and sodium and potassium, all very reactive. If we put our finger on the second group, and you'll remember from metals and acids that we did the other day, calcium and acid, they react together really, really violently. Okay. Now, the more reactive metals have less attraction to their electrons. So this is another key idea. More reactive metals have less attraction to their electron. And the reason that they react so readily is they get rid of those electrons because they're not as attracted to them. They're just like, okay, oh, you're around here. Oh, no, I lost you. It's not the end of the world. So they react. They lose them really easily. In comparison, less reactive metals have a much greater attraction. Okay? And they're more stable. Okay? So less reactive metals, greater attraction, more stable. So when we have a look here, this is our reactivity series, and I'm going to zoom in very slowly. Up the top, what is Au? Does anyone know? Gold. Okay. Now gold, when you think of gold, is it stable or is it quite reactive? Stable, okay? Now, I wear a gold ring, right? Now, can you imagine if this was really reactive and every time I put my gold ring on, I was worried it was going to explode? Okay? Gold wouldn't be a very good thing for rings then, right? Because if I put it on my finger and I was worried that it was going to explode at any second, it wouldn't make a very good ring. If I did this with potassium or sodium, remember that gross story I told you about the fingernails and sodium? Can you imagine making a ring out of that and just knowing that if you went to wash your hands, your finger would explode? That would not be particularly desirable in a metal. So we use really stable metals up the top and really reactive ones down the bottom. Okay. So as we move down this list, they get more and more reactive. Okay. Now we'll talk about hydrogen. You'll see it highlighted blue there and in brackets, and we will talk about it in a little bit. But what is the trend that we see here? How can we describe this? I've pretty much just said it, but what do you reckon? Any ideas around the room?
More downflow, more reactive it gets.
Great. So, describe the trend in the reactivity of ions as we move down, okay? As we move down the reactivity series of metals, their reactivity increases. So, as we move down series for metals, the metals become, apologies, they become more something and less something. They become more reactive. And if something is more reactive, good, less stable. So, what this means for us, and I'm going to leave this all up on the board so we can all see it. When we look at this list, if we think about gold, is gold stable as a metal or as an ion, so something that's dissolved? Where do we often see gold? Do we see it as a metal or as like a salt in a salt? We see it as a metal. So the metals at the bottom are more stable as ions. So things like potassium and calcium, they're in our like food, right? In like bananas and in our teeth. Do we have metal teeth? No, that would make us look like a James Bond villain, okay? But we do have metals as ions in our body, okay? So when the ions gain electrons, okay, this is what we call reduction, okay? Now, the standard reduction table, sometimes we refer to it as the SRT, shows the relative ease of reduction. So how easily it is for us to reduce something. So reduction is the ability for us to gain electrons, okay? So when we talk about the metal ions near the bottom, so I'll highlight on my list, these metal ions near the bottom, are they more likely to gain or to lose electrons? They're more likely to lose electrons. They're more easily oxidized, okay? And this means that they are more stable as ions. They get rid of their extra electrons, okay? Now, as we go up the table, things are more likely to be reduced. So what I'm going to write on my table here is up the top, reduce, and down the bottom, oxidize. What that means, reduce, is that we are going to gain electrons. And as we work down this list, we oxidize, which means we're more likely to lose electrons. Okay. So, almost there. What are three metals that are most stable in their metal state? If we look at our list here, what are the top three that are the most stable as a metal? Number one, gold. Number two, silver. Number three, great, so let's write those together. So the three are gold, silver, and finally copper. Now, three metals that really don't like being a metal. They want to react with, say, water or air or acid. What are they down the bottom? What are the three? Let's start with the most reactive is potassium. The second most is sodium. And the third most is calcium. So let's write those now. So potassium, sodium, and finally calcium. So what we're now going to look at is a very nice rule, okay? So this is the left over right rule, and all you need in order to exercise this rule is both hands in front of you, okay? And when you're talking about both hands in front of you, where can you actually apply this, and what do you get in a test? You get your own standard reduction table on the back of your periodic table, and you will need to use it. So make sure you have your periodic table in front of you right now. What I'm going to do is I'm going to pick anything, okay? And I'm going to zoom right in. We'll come back to the wording in a second. And I'm going to pick, I'll get to the question in 2 seconds. I'm going to pick anything on the left. So can someone pick one of these ions for me right now? Iron, okay? So I've got Fe2+ here, and I'll highlight that in yellow. So iron 2+. Can someone pick any element over on the right side? These are all my metal forms now. Magnesium, okay? Magnesium down the bottom right. Now, here's all we do with our left over right rule. If my left hand is above my right hand, I'm going to have a reaction. And it means that I'm going to react. If, for some reason, it was the other way round, so let me highlight the reverse now. Let's say it was magnesium ions and iron metal. My left hand is below my right hand. And in that case, no reaction will take place. That is it. That's the only rule that you need to be able to apply this year. So, can I get a show of hands? Who thinks this right now is the easiest thing ever? Okay? So, for everyone else, let's do one more example. If I pick two elements. On the left-hand side, I've got the ionic version. These E's in the middle represent electrons, because when I add a gold ion with a +3 charge to 3 electrons, it becomes gold metal. Now, Let me pick copper Cu2+ and calcium. Is copper 2+ above calcium?
Yes.
Yes. So is my left hand above my right hand? So will a reaction take place, yes or no?
Yeah.
Yes. Question.
What if they're in line?
What if they're in line? No reaction. The left hand needs to be above the right hand. Good. Chloe.
Why is it like only metals?
Why is it only metals? This can in some way happen with our negative ions, but we don't talk about it so much. We're giving you like the part truths right now. So, hey,
The EST practice for Lisa's class, where would I find that?
her desk.
Her desk?
Yeah.
Okay.
Hey.
If it's like gold with iron, since it's like if it's like higher above, is it gonna have like a bigger reaction?
If it's higher above, is it going to have a bigger? Yeah. Bigger difference, right? So, right now, let's do two together. So, let's have a look. Zinc metal and copper ions. So we need to have a look. You know what? I'm going to use two different colors here. I will help you out. Copper ions. We first go and find copper ions. Can you put your hand on your standard reduction table next to copper ions? The next thing you're going to do is you're going to find zinc metal, Zn. Is our left hand above our right hand? So will a reaction happen? Yes. And all you're going to write there is yes. Next. Would you expect a reaction to occur if silver metal, and let me use two different colors again, so silver metal and calcium ions, so pink and blue, would we expect a reaction to occur here? No. Why no? If we have a look, I've got calcium ions and I've got silver ions. Would we expect a reaction to occur? No, because my left hand is below my right hand. So if it helps you, you can write on your page, left hand below right equals what? Good. No reaction. Okay, it's one or the other. That's why we only give you one rule normally. But if that's going to help, so be it. So in this case, we have no reaction for silver metal and calcium ions. What I'm going to get you to do right now, can you go and fill in this table for me? You're going to need to put in the brackets there what the metal ion actually is, but using your table, or using your standard reduction table, can you have a go at filling in this table on page 30 for me?